Okay, so first we just see how to go for working with keil crash compiler. You're supposed to locate the keil MuVision 2. Sometimes MuVision 3 or 4 is being installed, but you need to open only keil MuVision 2. This software we have purchased it, and it is being installed in all our computers, and you can open it. So just click it, so you can see some of the projects already being opened, some of the software, coding being written. So whatever it is, you just close the project. So this is the appearance of your IDE, integrated development environment. Here you can see the project workspace, whereas this is an output window space where your code and all comes here. First, what you need to do, you need to create the project first. Go here, new project, and you can choose any of the folder. So I am creating a folder in D drive, so I name it as A section. That's it, A section 2019. Yeah, I created a folder. In this folder I create the project name. It's called MuC experiments, or you can even create the MuC experiments. That's it. So this project name should be only one, and you can create multiple files and you can attach to this project. So don't create the project name multiple of time, sometimes you'll be confusing yourself. So this is MC, it'll be MC experiments, right? Then it will ask for what microcontroller you want to work. So what I'm doing, so here you can choose anything. So I choose Philips, and it is P89V5192. This is 100% 8051 architecture only. So I'm choosing this because we are using this chipset for our lab. So I'm choosing this. So once you choose it, it asks for standard code, startup code. You say no. I tell you what is this startup code and all. Finished. So now you can go for project, and in the target you go for option for target. In this you supposed to choose for the device being already chosen, and the clock frequency is supposed to be 11.0592 because this is the crystal we have connected in our board. And output, in this output you just click create hex file. Finished. So you can do only these three. So target, device, target, create hex file. Finished. So now it comes fine. So the project is getting ready. You can see here microcontroller experiment. That's it. Now I'm going to create the file one by one. Go to file, new, right? You can type your code here. I'm going to save it, this file. When you save it, you go for experiment 1, 2, 3 in that name and extension, whether it is ASM file or a C file. This is right now experiment 6, so I name it as experiment 6 ASM. That I use file name as experiment 6. Of course, this is experiment number 6A, first program of experiment number 6. So I create in the name of experiment 6A.asm. Yeah, you create it. I have already. Yeah, this file is being copied. This is your experiment number 6 as being explained. We are going to equate the one of the RAM into this name, delay underscore val. This is my main program. This is my main program. This is the subprogram. The subprogram for generating a delay. Idea, you need to call the subroutine delay in this main program. In this main program, what we have done, we have switched off the LED first. Then we have gone for some delay. After that, again the all LEDs are being switched on, and after some time delay, it is being repeated. So this is what, simply the LED blinking, and in this instruction will call the delay program, whereas this instruction give the argument to the delay program. If you have right now #1, that is one time of this delay, and the delay value, and when I give a 2, so 2 time of this delay value being running here. That is an idea. So look at the program here. The delay value being copied to R0, right? So it is right now the value of this constant is 1. So don't confuse here. This constant being stored in this memory, and now the value of delay is actually 0 1, right? So the 0 1 being copied to R0, and we have some of the value for R5, R6, R7, and this loop 1 will keep decrementing R7 till it is getting 0. Once it getting 0, again it going to decrement R6 till getting R6 to be 0, and later on R5 is going to be decremented till R5 is getting 0. Once the entire loop 1, loop 2 is being over, then it comes to loop 4. Loop 4 will decrement the R5. This entire program will be running by R0 time. So try to understand this R0 being decremented. R0 is delay value. The delay completely works for some value, delay value. When you change this value, the entire delay value being changed. That's an idea. So I have stored it now. I attach the file now to this project. So where it is being chosen as C, but I have ASM. So this is an ASM. It comes some icon and all. Don't bother about this icon. Look at the type is ASM file. I attached it. So it comes here. Even when I close here, when I double click it, the program comes here. So this is what you have attached your file into the project. Now how to run this? So you can locate some of the icons here. You can click here to compile it. So it goes for assembling, and it shows any error and all. Otherwise, you can go to the project. You can see here the options, rebuild or build it or get something. So that also does the same, right? So now there is no error at all. Fine. Now we go for executing it now.